All right, here we go. We are in section 2, chapter 12. Title of the section is Analyze Arithmetic Sequences and Series. So arithmetic is a very common sequence. And so today in class we did all sequences, any type of sequence. And the next two sections, this section and the following, we kind of target a certain pattern of numbers. And this arithmetic is when you have a common difference between terms. That common difference we usually denote by the letter D, and if I wanted to add up all the numbers in an arithmetic sequence, we call it arithmetic sequence. Again, big word in this section is arithmetic, and that's when your sequence of numbers has a common difference. So like here, this sequence of numbers, would we define it as arithmetic? Well, first thing we would do is say, what is the common difference between all the terms? So you take every term, subtract the previous term, and you notice that, hey, we're adding 2, constantly adding 2 to the sequence, to the terms to get this sequence. And so therefore it is, yes indeed, it is an arithmetic sequence. So why don't you try this one? See if you can tell whether or not this is an arithmetic sequence. See if there's a common difference. Hopefully you did recognize that there is not a common difference, right? Now we're subtracting 5, then we subtract 6, then we subtract 4, then we subtract 7. So this is definitely a sequence of numbers. These are the terms, but it is not specifically called an arithmetic sequence because the difference changes. If you do have an arithmetic sequence, check it out. There is a rule. This rule 100%. We actually give you this rule like on the final exam. So you don't need to memorize it, but for you guys, you should definitely, I'll put it on your quiz and test as well, but it'd be good to have on your note card. So if you wanted to figure out the nth term, like let's say I said, oh, I have an arithmetic sequence, I know the first term, and I know the difference, like I'm adding 2 to terms, I could figure out the 100th term. I could figure out the 52nd term by using this formula. So let's go ahead and try to use the formula. Write a rule for the nth term of the sequence. And then once you've figured out the rule, it's like instead of having to keep going term by term, you could jump all the way ahead to the 19th term. So first of all, this is an arithmetic sequence, and you can see hopefully that there is a common difference of 7, right? We would subtract, oh my goodness, what did I just do? Stop! Oh gosh, what I did, I just twisted the whole thing up. There's a common difference. I don't know how to correct it. Of 7, and so we know the first term is 2, and using the formula we'd substitute in 2, right? We'd put in the 7, and then you'd clean this up. It's kind of a backwards distribution. We multiply 7 times n and 7 times -1, so we get 7n. This would be -7 plus 2 is -5, and this is your rule. So this rule, a sub n, will tell you, right, if I plug in n, I can figure out any next term. Or I can even go backwards. Woo! So if I want to figure out the 19th term, I plug 19 in for n, and check it out. This would be 128. So again, if I bounced 19 terms down, there would be a 128, right? Add another 7, the next one would be 135, and so on. Nice rule. Let's do it for the second example. So here's another example. It looks like we're dropping, by the way, right? Our difference is causing this arithmetic sequence to go down. So it would be a negative difference, and it is a negative 12. And again, you should check, like, is it arithmetic? But they told you that it is. I mean, they're telling you to write the rule. But in general, you should kind of check all the differences, make sure they're the same. To write the equation, we would plug the first term, which was 57. N, we want to keep that as n, and then put the difference. And again, notice the parentheses here, right? If you didn't use parentheses, it looked like subtraction. This is -12n. Finish the arrow, and this would be +12 plus 57 is 69. So this is the rule, a sub n. And once you have that rule, man, you have all the power, right? You don't have to figure out the next term by subtracting 12 and the next term by subtracting 12. You can jump around, and to figure out the 19th term, we just simply plug 19 in for n, do the math, and that is, again, if I kept dropping by 7, 19th term would be -159. Drop it. Next term, we just subtract another 12, and you've got the next term. Hope that made some sense. hey, could you go ahead and try to do this same thing, right? So these are arithmetic sequences. Figure out what the difference is, figure out the rule, and then use the rule to figure out the 20, again, totally random, figure out the 22nd term. So go ahead and try at least one of these two examples. When you're ready, hit play. And so there is the rule, right? You should have gotten 13 minus 4n. How did I get it? I know the first term is 9. I figured out the difference is negative 4. I plug into the formula. Again, be careful with this negative, right? You're going to distribute this. Is going to be negative 4n, and this would be positive 4. 4 plus 9 is 13, and there's my rule. How do I use the rule? Again, if I want to figure out the 22nd term, I plug 22 in for n. I calculate this, use your calculator, and then you've got the answer, negative 75. And you should feel like negative 75. That makes sense, 22 terms down. Second example, first term is negative 15. I figured out the difference was positive 6. I plugged into the formula. I cleaned it up. There's the rule. To use the formula, plug 22 in for n, calculate, and the 22nd term is 111. Oops, 2. There we go. So here we're given a term that's not the first term. So I need to figure out what the first term is, right? So they tell me the 11th term is 41. And they tell me the difference is 5. And then we got to kind of back up to figure out. And you could do this manually. I mean, you could just subtract 5, subtract 5. But using the formula, right, here's our formula. Realize I'm given the 11th term. So this would become a to the 11th. When n is 11. And so what is a to the 11? The value is 41. So and that sometimes gets tricky for folks to realize that this term is 41 and that n is 11. So they're not the same, value that I'm plugging in for n and the 11th term. Anyways, here it is, algebra solving for the first term. First term is negative 9. And then what did they ask you for? Oh, graph the sequence. And then figure out the rule. I apologize. Sorry. The first term is negative 9. And then to find the rule, I got to plug into the formula, clean it up, and that's my rule. If I use the rule, I should always get a linear, right? A common difference is kind of a common slope. I'm constantly moving 1 over for the next term, and then up, the difference, which would be 5. This is probably the hardest problem of this section. So it becomes a system of equations. I'm given 2 different terms and I'm asked to figure out the rules. I don't know the difference and I don't know the first term. So when I set these 2 equations up, right, you'll see right here, this is the setup. The 22nd term, I put 22 in for n, and the 22nd term is actually 87 is the value of the 22nd term. The 6th term, the actual value is 7. When I clean up these 2 equations, you'll notice it's a system of equations. It's a very easy system, right? Because I'm always going to have a sub n with no the coefficient. And you'll notice I would subtract the 2 equations. So subtract for a system, subtract. This will cancel the a sub 1 and subtract. And you should figure out that d is equal to 5. How do I figure out what a sub 1 is? The first term, I would plug into either of these 2 equations, right? Set d equal to 5. Solve for a sub 1. How do I figure out the rule? I go back, plug in the first. The first term is 18. The difference is 5. Clean up the rule, and I am done. Again, I would love to see a sub n here circled. Shame on the book, right? They should have presented their rule with a sub n. This rule tells you any term. Which term? The nth term. I want the 100th term. I plug 100 in for n. Nice job. We'll practice that system equation. Actually, let's practice it right now. Take one of the... Actually, these are different. This is the system, right? Notice they give you the 5th term and the 20th term. This is a big to-do. We'll definitely practice this problem in class, but you might practice it now. And this one here, you're just trying to figure out the first term. Again, I would take a good 5 minutes and try these problems. When you're ready, hit play. Woo! And so you can see it's a lot of work. Here's all my work in blue. Basically I plugged 107 in for the 15th term. N is 15. The difference was given as 12. I solved this for the first term is negative 61. And then I clean up I have to figure out the rule. So So I plug the first term in, the difference, and clean it up. Then they asked me to use the rule. Again, just busy work, but whatever, right? Figure out the 22nd term, so I plug 22 into my rule, and I get it. The second one, here's my system, right? So when you're told the 5th term is 91, that means n would be 5. You're told the 20th term is 1, so n would be 20. I do a little cleanup. Basically, I just subtract the 20 and the 1. I subtract the 5 and the 1. And now I'm in a system, right? Here are my two equations that I'm solving. And you should say, and it's always going to be this case, that I will eliminate the a sub 1 by subtracting one equation from the other. I did get n to be -6, and then I figure out the first term by plugging into either of the original equations, and then I clean it all up and present my rule, and there she is. And then they also wanted to know what the 22nd term is, which I don't think I did. Oh no. But you'd plug 22 in for n and calculate. Not a big deal. So if you do have an arithmetic sequence and you want to figure out the sum of that, we would call it a series, and we have a rule. So again, this formula will be given on the final exam. I would definitely write it on your note card. Beautiful formula. It's saying the sum of however many terms. You want to figure out the sum of the first 100 terms, n would be 100. We basically need an average of the first term and the last term that you're interested in divided by 2. So it is the mean or average of the first and nth term. So here in this case, hey, could you find this sum of this arithmetic sequence? Nice that they told you it was arithmetic. If they didn't tell you it was arithmetic, you'd have to figure it out by plugging 1 in for I, then 2 in for I, then 3 in for I, and seeing if there was a common difference. But they told it to us, so that was nice. I have to figure out the first term and the 15th term, right? Our formula needs that first term and the nth term, which in this case would be 15th term, which ends up being 54. And then the formula is pretty easy to use. N is 15, first term, last term, take the average, and you're done. Nice formula. If you want to try this last problem, go ahead. Again, they tell you it's an arithmetic sequence, so I don't have to determine it. Plug in 1 for the first term, plug in 18 for the 18th term, use the formula, boom, you should get 702 for the answer. I think I did some work. I did, yep. So I got the first term when I is equal to 1. I got that a sub 1 is equal to 73. And when I is equal to 18, the 18th term, I got that was equal to 5, and then you would use the formula. So the S18, I should have prepped this, I apologize, is 18 parentheses, take the first term, 18, oops, excuse me, first term was 73, add to the 18th term, which is 5, divide by 2. Sorry for the messy writing. And then again, use your calculator, figure it out. Nice job. We'll practice this tomorrow in class. We'll see you then.